Hi everyone. This video discusses solving equations. It starts with revising the types of equations you learned to solve in grade 8. And then it moves on to solving equations that involve fractions. If you'd like to know about solving quadratic equations, that will be in the next video in the series. For now, we're just going to look at equations that have only one solution. Let's get going. Let's start by solving equations using inverse operations. Now, inverse operations are things like the opposite of adding would be subtracting, or the opposite of multiplying is dividing. Now, here's the first example. Solve for x. Negative 3x plus 4 is negative 8. And the aim is to have only variables on one side. So with that positive 4 on the left, if I subtracted 4 from the left, I'd have no 4. But I need to do what I do to one side, I need to do to the other side. So I would need to subtract 4 from both sides. What that ends up looking like is I'd say negative 3x is equal to negative 8 minus 4. So I get negative 3x. On the right, I have negative 12. And now to solve for x, the opposite of multiplying by negative 3 is dividing by negative 3. So I divide both sides by negative 3. And I get that x is positive 4 because negative 12 divided by negative 3 is positive 4. Now, if you want, you can always check your answer. So on the left, if I substitute my solution in and work out what it is, so negative 3 times 4 is negative 12 plus 4, I get negative 8, which is exactly the same as what the right-hand side is. So a really nice thing about solving equations is that you can always check your answer. For the examples that follow, I'll show you a check in the next one, but I won't check all my answers. But you're welcome to do that in your own time. My next question asks me to solve for y. In this question, I have y's on both sides of the equation and constants on both sides. So let me keep the y's on the left and the constants on the right. So the opposite of adding 2y would be subtracting 2y. And the opposite of subtracting 2 is adding 2. Now I've grouped all my variables on the left and all my constants on the right. I can now simplify both sides, divide both by 3, the coefficient of y, and get that y is 3. If I'm not sure that my answer is correct, I can always check. Now in this case, my left and right both have y's in them. So if I substitute in the left-hand side of y is 3, I get an answer of 13. And if I substitute on the right-hand side, 2 times 3 is 6, plus 7, I also get 13. Which means that y is equal to 3 is the correct answer to this equation. Now let's move on to equations with fractions. Let's start with some really simple ones. So in example 4, I'm asked to solve for x. X divided by 4 is 9. Now you might already be able to see the answer, but let's use inverse operations. So the opposite of dividing by 4 is timesing by 4. 9 by 4 is 36. And I could check the answer. 36 divided by 4 is 9. I could check that one in my head. Let's get a little bit more complicated. Here I'm dividing the whole piece by 3. So the opposite of dividing by 3 is multiplying by 3. Now if I multiply the left by 3, the 3 will fall away. So I get 2x minus 1 is negative 4 times 3, which is negative 12. Now I can solve as usual. The opposite of subtracting 1 is adding 1 to both sides. And so 2x will be negative 11. If I divide both sides by 2, I'm going to land up with an improper fraction of negative 11 out of 2. This is a perfectly suitable solution, but if you want to write it as a decimal, you can also do that. Now in this equation, I've got multiple fractions. So let's start by making all of my denominators the same. And the lowest common denominator for all of them will be 21. So for the first term, 7 times what is 21? 7 times 3. So I must times the top by 3. In the second term, 3 times what is 21? 7. And the last one, it's the same thing. Now, the nice thing about solving equations with fractions is that you can multiply both sides by your denominator. Now, if I multiply both sides by that denominator, the denominator will in effect fall away because it won't be used anymore. So, what I get is 9x minus 7x is 14. I could simplify the left, gives me 2x is 14. And divide both sides by 2, I get x is 7. Now, since this is an equation, you can multiply both sides by the denominator to make the question easier. Remember, you can't use this method for any fraction, especially if the fraction is an expression. The only time that you can multiply by a denominator would be if you have an equation and you have two sides, so you're balancing the equation by multiplying both sides. Be careful not to simplify fractions that are not an equation using this, because that won't work. Let's go a little bit harder. Now, in this equation, I'm solving for b, but also there are two sections that are problematic. The negative 3b is not a fraction, and 3 1/4 is a mixed number. So let's start by writing everything as a fraction, and 3/4 I'm going to write as the improper fraction. So the way I work out the numerator is 3 times 4 plus 1. I get 13 out of 4. The next step I'm going to do is I'm going to make all my denominators the same. So the lowest common denominator that's going to work is going to be 8. So all of my denominators will be 8. Now I've got to think how to make an equivalent fraction. I've got to double the denominator 4, so I have to double the numerator. This next term stays the same. The next piece I need to times by 8, and the last bit I need to double. Now again, because I have an equation and all my denominators are the same, I can multiply by my lowest common denominator, thereby removing the denominators, creating an equation that's far easier to solve. Now let's see, 18 minus 24 gives me negative 6, because those are like terms. And I'm going to add 1 to both sides. So I'm going to get negative 6b is 27. I'm going to divide both sides by negative 6. And then I'm going to simplify my fraction. 3 can go into the top and the bottom. So 3 goes into 6 twice. 3 goes into 27 9 times. And so my simplified answer is negative 9 out of 2. Again, I could write that as a decimal if I wanted to, but I find it easier to write things with improper fractions. Now just note, if you look at my handwriting of this question, sometimes the b and the 6 look the same. So make sure that when you write, you pay attention to what you're doing, and also ensure that your variables and your constants look a little bit different. Now this equation has more than one term on the top of each fraction. However, I'll still go about it the same way. Now I've decided in this example to not show the step where I make all the denominators 12. It's up to you if you show this step or not. If you'll find it easier to do, you're welcome to do, or you can skip it. So I'm going to start straight away by multiplying both sides, each term, by my denominator of 12. So the first fraction already has a denominator of 12, so if I multiply by 12, I'm just going to get the numerator. The next fraction, I would have had to multiply by 3 to get a denominator of 12. And then the denominator of 12 would fall away. And the last fraction, the denominator, I would have had to multiply by 4, which means to create an equivalent expression, I'd have 4 out of 12, but the 12 will fall away. Now I've got an equation to simplify. Be careful with that brackets. Both terms are being multiplied by negative 3. Now let's group my like terms together on the left. I get negative 7p. And negative 3 plus 3 is 0, so those can fall away. Gives me 4. Now I can divide both sides by negative 7. And so P is going to give me negative 4 out of 7. Now you'll notice in some of the examples I give, I've made sure that some of my solutions are not whole numbers, just so that you can get the idea that the solution of an equation could often be a fraction. Now in this last example, everything looks a little bit intimidating. However, let me start to rewrite each term as a fraction, because remember, half times 3x plus 2 is the same as 3x plus 2 divided by 2. Similarly, 2/3 times x minus 1 is the same as 2 times x minus 1 over 3. The last bit I'm going to write over 1, just so that I don't forget to use fractions. Again, I'm not going to show this term where I make all my denominators 6. I'd need to times top and bottom by 3 for the first term. For the second term, I'd need to times top and bottom by 2. And for the last term, I'd need to times top and bottom by 6 if I wanted all the denominators to be 6. Now I'm going to skip that step of showing all the denominators are 6 and just multiply straight away to remove the denominator. Now I've got some expressions where I've got to multiply out the brackets. Let's do that. Minus 4x plus 4, careful with the signs, and 12x minus 18. Now I'm going to firstly add my like terms together. So 9x and negative 4x gives me 5x. 6 and 4 gives me 10. That gives me 12x minus 18. And for a change, I'm going to put the x's on the right. So I need to subtract 5x from both sides. So I get 12x minus 5x on the right. And I need to add 18 to both sides. So I get 28 is equal to 7x. I divide both sides by 7. And I get x is 4. Now it doesn't matter that x is on the right and the constant's on the left. It still means exactly the same thing. That brings us to the end of solving equations with fractions. In the next video, I'm going to discuss solving quadratic equations. So until next time, goodbye.